Welcome back. Last lesson we looked at input devices, and in this lesson we'll look at output devices. In this lesson we'll briefly review what digital output means. We'll look at a range of output devices and we'll look at examples including Cad Cam and 3D outputs. Output is anything that is produced by the computer which is useful to us as humans. It could be readable output so that we can visually see it, or understandable in some other way such as sound, or it could be useful to us, for instance controlling some kind of equipment, vehicle, heater. But in any case, all three of these types of output are something that we need as users. In the input lesson, I talked about analog to digital conversion. That is turning the smooth analog data of real life into number form. When we do output, we do the same thing in reverse. We take the digital values inside the computer and turn them into analog outputs, and a very good example would be sound. Sound waves are analog measurements. We looked at how we can turn those smooth analog signals into numbers inside the computer, and it works in the other direction when we're talking about outputting sound. The digital numbers inside the computer are converted back into a smooth analog sound signal. The more accurately and the more frequently we can output that digital information, the more realistic and rich the sound will be. In general, there's a quality and capacity trade-off. That is, signals such as sounds which are more rich and realistic require a greater number of digital codes, and the codes are larger numbers. So our quality is often limited either by the amount of storage that we have available, or increasingly in the modern world by our bandwidth in transmitting the data, for instance as we download off the internet. I want to briefly talk about another form of output, which is Cad Cam, which is linked to the use of 3D printers. That is, we can design 3D solid devices on the computer, make our design, test our design without ever creating any real objects. And then we can output those devices using a 3D printer, and a 3D printer will spray or glue together some kind of solid matter. It might be a resin or a plastic, it could even be metal, and by sticking that together, actual 3D objects are output. We can also combine input sensors with a sort of output device called an actuator, and an actuator will move, for instance, a robot around, and by combining sensors and actuators you can create some kind of robotic system. Most robots don't look like humans. These are examples of robots in a factory, but they can work automatically without a human controlling them. There would be humans around to make sure that nothing's gone wrong, but the robots can do a lot of the work without anybody having to step in. Robotics is an example of what we call a control system, and there are lots of other kinds of control systems. For example, let's imagine a bakery, and there's a computer system that's controlling the temperature of the baking ovens. The system must have some kind of input so that the computer can tell how warm the oven has got. Inside the processor, there is some sort of standard of how warm we want the oven to be, and then the computer can control an output mechanism, for example a burner that can raise or lower the temperature. And in this way the computer is constantly monitoring and adjusting the system. The computer outputs affect the system, and then the input devices feed back the results into the computer. In this way, the system is maintained constantly at a desired level. This is called a control system, and this is called the control loop or the feedback loop. By using this kind of system, a computer can work constantly without a person there to keep a system within the bounds that we have decided in advance. The system is maintained in a stable state. For example, the bread gets cooked. So to recap, you should now be confident that you know what computer output is, and you should be aware of a range of output devices, including 3D printers and control systems, and how input and output devices work together to stabilize a system under computer control. There's an output section in the hardware workbook, so if you're my student, have a look at that and fill in the output section to show your understanding. We've now looked at input and output, and in the remaining lessons we'll look at memory and storage. Bye for now.